Hello, today I am going to give a talk on how to learn any computer language. Friends, as the day passes, a large number of computer languages comes up. Some of them are still in use. Some of them are out of use. And many innovation comes in with new different languages. Every language has its own identity. And so, a wide range of languages are available in the literature of computer science. And so, the natural question is how many languages one should learn? It's a very obvious question that how many languages one should learn. And it is quite difficult to learn all languages also at the same time. So, how to answer this question? So, to answer this question, this is my video. How to learn any computer language. And my claim is if we understand any one computer language very thoroughly, then you can learn any other language with very easily and with very less time, with less efforts. Because learning of a computer language is to develop the logical thinking. It's a process of logical thinking. And in programming, the logical thought, the process of logical thinking is converted into some certain symbols and certain words. That's all. So, by learning a computer language, we have to learn a thought process behind any computer program. And if our thought process goes very correctly, then whatever may be the computer language, you just have to use the appropriate symbols and words from that language, and you have to fit your thought process in that symbol. That's all. So, how to learn any computer language is the basic question. And I have answered that one should learn only one computer language very thoroughly. Other languages you can learn it very easily. So, what is the process of learning any language? What is the process of learning any language? There are basically three steps of learning any computer language, out of which first two steps that I am going to discuss now are language independent. These two steps are, first step is algorithm and second step is flowchart. What is algorithm? Algorithm is a very simple concept. Whatever the problem you are solving means you are writing a certain program to address some problem. So you have to write all the steps sequentially, and you have to take every care that your process you have converted in a stepwise procedure. So algorithm is a simply stepwise procedure of solving any computer program. Right? It is a stepwise procedure. So you have to start somewhere, you have to end somewhere, and in between there is a process. In the process, there are some milestones like data input, data output, result output, and in between a process. So we have to take appropriate care of making the list of steps, stepwise procedure of solving any problem. That is algorithm. It means that algorithm is a logic. Algorithm is a logic by which you are solving the problem. Now, algorithm is for the same problem, we may have different algorithms because solving a problem is a logic, and logic is different from person to person. Some may solve the problem by 10 steps, some may solve the problem by 3 steps, some may require 100 steps, so logic changes. And so algorithm is nothing but a logic of solving a problem. The second step comes is flowchart. Now this flowchart is a pictorial diagram. We are using some geometrical shapes like oval, then rectangle, then rhombus, then parallelogram, arrows, triangle, like this. We are using these symbols. We are using arrow lines. And we are converting now our algorithm into a flowchart. That means algorithm in the text form, a stepwise procedure in a text form will be converted into a pictorial diagram drawn from top to bottom with appropriate symbols and arrow lines. So it makes to understand your problem very simple. So it is a pictorial diagram that makes very easy to understand what are my important steps, where I am going to repeat it, where I should take the care. And like this, you will come to know different milestones in your algorithm and your program. So it's a flowchart. So algorithm and flowchart is a two-way procedure by which beginners can develop their logic. So I will insist every beginner to write hundreds of algorithms, convert these algorithms to flowcharts, and try to develop your logic. So logic development will be very perfect if we write many algorithms and many flowcharts. These two steps are computer language independent. Now third step is program writing. This program writing is definitely dependent on computer programming language. So let us start with this. Now can you imagine how we have learned our mother tongue? Can you imagine how we have learned our international language English? Very simple. We have started with alphabets. Exactly same thing we have to do. We have to understand what is the character set that is the base of the underlying language which I am studying. And this character set has different parts, different sections. For example, alphabets A to Z. Now, when you say alphabets A to Z, we must ask the question whether alphabets are capital or small or they are case sensitive, because different language has different requirement. So we have to understand, because if they are case sensitive, it doesn't matter you use capital A or capital B or small a or small b. But if they are case sensitive, then you have to be very much careful about it. Alphabets. What are the numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These numbers we are going to use. These are called numerals. But remember the difference. In numbers, there is a one number which is very much similar to an alphabet, and that is 0. 0 in numeral and O in alphabet, they seems to be same. When we write 0, some may read it as O. When I write O, some may read it as 0. So in order to avoid this confusion, we have to understand what that particular language is doing to make the distinction between O and 0. Arithmetic operators. How I can add, how I can subtract, means what are the symbols used for addition, subtraction, multiplication, division and power. I have to understand these symbols, and these symbols are called as arithmetic operators. Usually there is no problem for addition and subtraction. Plus and minus, usual symbols that we have learned from our childhood, school days, are used as it is. For multiplication, dot we may sometimes we use. X we may sometimes use. But dot and X may have some other meanings also. And that is why multiplication is used by showing star. It's a usual practice. Division. Our regular division symbol is not used in computer language. Slash is used for division. Then how to raise the power? 2 raised to 10. How to raise this power? So for that, different languages has different symbols. So we have to understand these arithmetic operators. We have to understand then relational operators. How can I compare less than, greater than, less than or equal to, greater than or equal to, not equal to. These are the various relational operators by which we are going to compare two things. So what actual symbols are used in particular language? Some languages may use your usual less than symbol. Some languages may use .less. So there are different approaches for comparison, and we have to understand language to language what are the relational expressions, relational operators. Then logical operators. So it's a combination. We have to use not, or, and, XOR, something like this. Then somewhere we have to understand what do you mean by constant and what do you mean by variable. See, the constants are those which remains same throughout the program. That is constant. Its value will never change. That's constant. Variable, that is going to change from atom to atom, object to object. So there is a distinction between constant and variable. We have to learn in every language how constants and variables are declared, how we can define the variable, what type of combination of alphabets, numerals or any other characters are allowed to define variable, how long variable name can be, and if it is too many long, then how many of them first few characters are significant. We have to understand these things. Once we understand constant, once we understand variables, once we understand arithmetic operators, then now we are in a position to write arithmetic expression. Some languages may have a feature of declaring variables by its types. Maybe integer variable, maybe real type of variable, maybe character type of variable, many different types of this. So we have to use now appropriately, legitimately constant, variable and arithmetic operator to get another creature called as arithmetic expression. So arithmetic expression is a very important concept because that is actually responsible for performing certain calculations. And so we have to write arithmetic expression with a very due care, very perfect arithmetic expression. Now we have a choice of comparison also. We can compare two constant, we can compare two variables, we can compare two arithmetic expressions, or we can compare different combinations also. So how to compare them? One is less than the other, one is greater than other, one is not equal to other, one is equal to other, something like this. So for such a comparison, we have to use, of course, relational operators. Less than, greater than or equal to, less than or equal to, not equal. So arithmetic expression, logical expression, relational expressions, these are the some new features we have to develop before writing a program. Now let me explain you the difference between arithmetic expression and relational expression or logical expression. See, arithmetic expression will give you a numerical value from say minus infinity to plus infinity. By saying minus infinity to plus infinity means the most smallest value up to most maximum value. That's all. Whereas relational and logical expression will be either true or false. They are in a true state or false state. So there are only two possibilities. One for true, zero for false. Once we understand this, then we have to understand what is the program structure, how to start writing a program, what will be the first step indicating that program is started. So beginning of the program is one of the important steps we have to understand. And when we are going to end the program, we have to understand how we can conclude the program, how we can stop the program, how we can end the program. So beginning and end of the program, we have to understand these concepts very clearly. Then you know that every system has three components: input, process, output. Program is also a system, a small system. Even if you add two numbers a plus b, it is also a system because you are fetching two numbers a and b, you are adding them, and you are giving the output a plus b equal to c. So that is why it is a system. It falls in the category that input, process, output, that is why it is a system. Once we accept this, once we understand this, then while writing a program, we have to understand what are the possible inputs, which kind of data I am giving to the program input. We have to understand this input. At the same time, we have to understand what kind of output will be going to be generated, because this input output requires different variable names, and we have to be very careful enough in declaring input variables and output variables. So programmer must have his own ideas clear about the input and output. Now input means giving the data to the computer, giving the data to the software. Output means getting the result by computer, by software. Question is where, from, how I can give the data to the computer. And the very first approach is through keyboard, that is called as standard input. How to get output? The standard output is monitor, console, on which I can see my output. Then I can take its a printout, I can save it and all those things. But the standard output device is monitor. Standard input device is keyboard. So I have to understand in the computer language that which is the command responsible for fetching the output from program to monitor. Which is the command responsible for fetching the data through keyboard and accept for the programming process. Input and output command. Once you get the data, then you have to understand what are the different processes, what are the arithmetic expressions, what are the logical expression, what are the relational expression, what are the control statements. So control statement means under certain conditions you are going to perform certain conditions. Under certain conditions we are going to perform certain operations. Control statement. So control statement may be repetitive class of statement that is called as loop. So statement like if then, if else, loops, these are the control statement. There are certain branching statements that you are diverting your control going in a sequence to some other step. That is a branching statement. So if we understand all these very clearly, then I think your logic will be very up to date and this will help you in writing the program. Then you need how to format my output, because formatted output is very easy to understand. So how to format the output? Can I get the output in a tabular form? How to format the output? How to save my output? How to save my program? How to edit my program? How to append my program? All these are the operations we have to understand. Usually, beginners start with a very simple program, that is hello. Then they start with addition, subtraction, multiplication, division, like this. So it is a stepwise making your program little bit larger. And that's a good thing, that we should start with a simple program first. Once you get the confidence, you try for difficult program, and so on. So friends, this is what I have to discuss about how to learn any computer language. I think even if I have not discussed too much, but whatever the points I have discussed are most important points, and it will help you in um starting your programming career. Thank you very much.